Let me now at this point turn to Sharon Camp and let her take over the program from here.
Good morning, everyone. So the state of science education in the United States has taken kind of an ugly turn with the introduction of the next generation science standards. And so one of the things that the CO2 Coalition wanted to do was to get involved in making science education materials, which we're gearing toward elementary through middle school, and primarily homeschoolers, charter schools, and magnet schools, if they're interested in them, to come with true, honest science written by scientists. And the CO2 Coalition has got an amazing group of scientists and economists and business people and people across the entire spectrum to use as resources for this. So school choice in America has become very, very popular with the states, especially since people have discovered that things are not quite so well in the public education system. And this was brought to everybody's attention during the lockdowns for COVID. So parents are becoming more concerned about exactly what is being covered in the schools. There are 45 states that permit public charter, 50 states permit magnet schools, 50 states permit homeschooling. Pennsylvania allows all three. They also provide a state tax credit scholarship for educational improvement and educational opportunity. So there are a lot of people in Pennsylvania that clearly are interested in taking the education of their children into their own hands. 3.7 million students now are being homeschooled in grades 0 through middle school. Mostly middle school seems to be the highest one, with North Carolina, Florida, and Georgia all having the highest percentage of homeschoolers. So why would you homeschool for education? Because there are a lot of people that aren't particularly knowledgeable about science or even comfortable with science, and part of that has to do with the dismal science education that a lot of us received when we were in elementary school. We've taken little kids who are normally natural investigators, and by the time they get into high school, they hate science. Somewhere along the way, we're failing our children, and probably failed you in the past as well. However, it's gotten a lot worse. The schools no longer teach the scientific method. They now have replaced that with what they call science and engineering practices, which I'll talk about as being completely different. They also no longer teach critical thinking. And so this is where the indoctrination part comes in, where they tell the students not how to think, but what to think. And this is a huge problem because learning how to think is so easily taught in science, but they are not doing it anymore. And of course, now all of us are becoming suspicious that this is on purpose. So to try to take that into their own hands, parents have decided, well, I'm just going to bring you home. We'll figure out how to do it on our own. So public education really seems to have become much more interested in indoctrination than they have in education. And there's no area that's this more true than in science. So the next generation science standards were standards that are presently used by 45 states in the country, including the state of Pennsylvania. It does not include the scientific method. It was purposefully left out, and it does not include critical thinking skills. Now, the interesting thing about why it was intentionally left out is because the argument was that it requires the use of a hypothesis and experimentation in a lab, and not every scientist will approach a problem in the same way. And so they'll take out subjects like geology, for example, where you can't really set up how does plate tectonics work in a lab, or some kind of an ecology study where you really have to do it out in the field, and they'll use this as a justification for not teaching the scientific method. It is a way of approaching a problem. It's a way of coming up with a question and possible choices for the outcome, and then seeing if your choices work. I mean, my mechanic uses the scientific method when he's trying to figure out what's wrong with my car. So it's widely applicable, and again, is a way of thinking. It also requires an understanding of the difference between pure science and applied science. So when they replace engineering practices with the scientific method, they're taking pure science and replacing it with applied science. So let's talk about what the difference is there for a minute. The best way I can explain this is the difference between a chemist and a chemical engineer. So a chemist goes in the laboratory and tries to come up with some kind of a process. And it could be some kind of a pharmaceutical. It could be a way to identify different compounds. My thesis research was trying to identify unknown products in a North Carolina river that water was turning pink because of the effluent from carpet manufacturers. What is this stuff? How do you detect it? So on and so forth. Once the chemist has designed a process, the chemical engineer's job is to scale it up to manufacturing. So let's say that you've discovered this brand new type of glue, adhesive, and you want to bring it to market. The the chemical engineer, is the one who's going to scale it up to the industrial production. He already knows what it is you want to do. He's just got to find some way to do it. But it's the scientist, the chemist, that does all the research, figures out the chemical reactions that are involved, and comes up with the actual process. So there's the difference in thinking right there. And that should tell you something, because what they want these students to do is, instead of thinking for themselves, is to accept a given piece of information as fact and then work from there, instead of trying to determine, is this really a fact or is it just bad science? And so that's the problem. So the next generation science standards are the standards that are written for K through 12 education. And they are expectations for what students are expected to be able to do. So when I started teaching, back when the dinosaurs roamed the planet, they threw a book at me and said, "Here, teach this." Like, sure, no problem. How far am I supposed to go? What do you want me to cover? How fast should I cover the material? What are my kids supposed to be doing? You'll figure it out, right? So the whole idea of standards was to help teachers around the country be able to come up with, okay, this is what we're going to do and this is how we're going to do it. And then the selling point for the next generation science standards was, okay, if I live in Pennsylvania and I move to Georgia, for example, instead of having to learn a brand new curriculum and be in a different pace and so on and so forth, everybody will be on the same page. Wouldn't that be wonderful? And then they also said, well, this is terrific because you've got big organizations like the National Academy of Sciences and the American Association for the Advancement of Science and the National Science Teachers Association. All these people are supposed to know so much about science, and they're going to get in there and they're going to write the standards, and it's going to be great. And what we didn't realize is what they all had an agenda, and they were slowly but surely implementing it. So what are the components? It's a little complicated. They have 3 different parts that they refer to. One is what they call the cross-cutting concept. And this is like just the core information. This is the concept you're supposed to understand. Then the science and engineering practices is what they've replaced with the scientific method. Okay, this is what you're going to be able to do once you understand this core concept. Disciplinary core ideas, those are the main science concepts. And then the cross-cutting concepts are where you're going to find this in different areas throughout the science curriculum. So they're trying to, instead of the way we used to do it, which was, you'd study one unit of biology maybe, and then a unit of physical science, they're trying to bring it all together so that the areas overlap will be covered as overlapping areas. Again, it doesn't sound like it's a bad idea, but they've left out the scientific method. So the scientific method then is discouraged because not all inquiries require the use of a hypothesis, which I strongly disagree with. Every scientific investigation starts off with a question. Not all inquiries occur in the lab, but that doesn't mean you can't use the scientific method to figure it out. Not all inquiries require solutions. So you'll see in the standards, I'll have some up there, solve this problem. It's like, that's the engineering part, It's like, I'm not here to solve the problem. I'm here to identify what's going on. What's the science fact that's going on? And it doesn't include models. The scientific method does not include models. And so part of this is to sell the whole ideas of models, which is one of the biggest problems. So if we take a look at these are the list of things that they consider to be the science and engineering practices. And in nowhere do they have anything about a hypothesis. They say, ask questions and define problems. So in a scientific inquiry, you always come up with a hypothesis. It's not just asking questions, it's to ask a specific question, and then to design an experiment to find an answer to that question. And some of these look like part of the scientific method, and they are. Engage in argument from evidence, obtain and communicate information, be able to explain what's going on and why. But they've left out the key part of the scientific method, which is independent thinking. So this is what the next generation science standards look like. You've got 3 different colors at the bottom, engineering practices in blue, and the cross-cutting concepts are in green, and then the core ideas are in orange. And then you've got all of these standards that the students are supposed to do. This is what they have to be able to accomplish if they have learned the material. And I just pulled one out of the air, matter and energy in organisms and ecosystems. MS stands for middle school. This is what the specific instructions are. Use a model, construct a model, give evidence based on a model. So now we've got not the search for empirical information, it's all based on models. And if you take a look at a lot of the science, and I'm going to use that term loosely, research in magazines, they'll all say, this model, okay? So let's define exactly what a model is. There are 2 different types of models. There's a predictive model, and then there's a model that's used to explain a concept, an abstract concept. So an example would be styrofoam balls and toothpicks to represent the shape of a molecule. That's a model, okay? But the predictive ones are the ones that they want the students to use. And the predictive ones we could think of as being like a weather model, okay? They have to have supercomputers for weather models. The weather models can predict with accuracy 3 days in advance, 5 days if they're lucky. Anything past then, don't even bother to look at it because it's not going to be accurate. The model is only as good as the information that you put into it. And when you're looking at extremely complicated systems like weather or climate, you don't know all the parameters. Here's another trick. They leave out parameters that will give the wrong information. So for example, we know for a fact that water is the major greenhouse gas in the atmosphere, and that it is one of the main things that determines climate around the world, and clouds are equally important, but the climate models don't include either. So is that oversight, or is that because they don't want to? And so now we start to look at why the use of modeling is so important, because they can come up with a model, tell the kids, okay, this is what's real. I want you to base all your arguments on this model. So this is from the Pennsylvania Integrated Standards for Science, Environment, and Ecology. It is verbatim what I just showed you in the NGSS. Just a really quick thing before I turn the podium over. I hope I've left you ladies enough time. So this was a particularly interesting article. Jonathan Osborne, Professor Emeritus of Education at Stanford University, which actually has gotten kind of a black eye the last few months, but his proclamation is that the goal of science is the achievement of consensus. And if anybody is a scientist, they understand that scientists argue with each other about concepts all the time, constantly. But that's how it grows. You don't reach consensus necessarily unless it's something that nobody argues with, like photosynthesis, which sounds really super simple, but when you start getting into the chemistry, they even argue over that.